we're going to jump into triangles. We haven't done much with triangles. We're going to do a lot with triangles this year, so we're going to start here in 3-4. The first thing, well, we all know triangles have 3 sides, which means they also have 3 angles. And you probably knew that all 3 angles of a triangle add up to what? 180. It's called the triangle angle sum theorem. It's a rule in geometry that you have to follow. The measures of the angles of a triangle add up to 180. Okay, we will be using that all year, so don't forget it. You probably already knew it. Triangle angle sum theorem. It has a name, so that's what I'm going to call it, triangle angle sum theorem. When you use it in a proof, you can use the name, triangle angle sum theorem. You don't have to write this all out. Okay? I am now jumping down 2/3 of the way, sorry it's out of order, to where all these blank lines are. We're going to fill in those blank lines. Like exterior, yep. An exterior angle of a polygon is formed by one side of a polygon and the extension of another. An exterior angle is formed by one side and then the extension of another. Exterior, what does the word exterior mean? On the outside. So an exterior angle is going to be on the outside of the polygon. In this case, we're talking about triangles. So here we have the right side of the triangle, and then an extension of the left side. Extension, it goes past, it's extending on. Angle 1 would be an exterior angle. It's outside of the triangle. It's formed by one side and then the extension of another side. Extension, it's going past the vertice, the intersection. If I extend the bottom and use the left side, here would be another exterior angle. Outside of the triangle, formed by one side of the triangle and the extension of another. If I extend this left side and use the bottom, I have another exterior angle formed by one side and the extension of another. What do you know about these 2 exterior angles that I have here? They're vertical, so they'd have to be what? Congruent. Good. This angle between the extensions, would you consider that an exterior angle? Well, it's outside of the triangle, yes? Yes, but what are the 2 rays that form it? Is it a side and an extension, or is it 2 extensions? 2 extensions, so we would not call this an exterior angle of the triangle. It has to have one side and one extension, but this would not be because there are 2 extensions. Okay? Remote interior angles, then, are 2 non-adjacent interior angles that correspond with each exterior angle. Remote interior. Since we're talking about triangles, we're going to have one exterior angle, and then the remote interior angles are going to be the other 2 on the inside. The interior meaning inside. If I look at this exterior angle 1, then its remote interior angles are 2 and 3. They're on the inside of the triangle, and they are non-adjacent to the exterior angle. So you're going to pick the 2 angles that are not touching the exterior angle. Those are called your remote interior angles. They're remote according to that exterior angle. If I have a different triangle here, an exterior angle formed by one side and the extension of another. So this angle 4, we'll call it, is an exterior angle of the triangle. Its remote interior angles, 2, 3, we'll call that angle 1, would be 2 and 3, because they're on the inside of the triangle and they're not touching the exterior angle, so I call them the interior ones, the remote interior. Why do you have to know that? For your second theorem at the top of the page. The second theorem at the top is called the exterior angle theorem. which states the measure of each exterior angle equals the sum, add the two, remote interior angles. So the measure of angle 1, since it's on the outside, is going to equal the sum of 2 and 3 together. Your exterior angle equals the sum of the two remote interior angles. Okay? Measure of an exterior angle equals the sum of the two interior angles. It has to be the two that don't touch it. You don't want the adjacent angle. 2 rules today. Triangle angle sum theorem. All 3 angles add up to 180. Exterior angle theorem. The exterior angle equals the sum of the two interior ones. We have, well, 7 different classifications for triangles. You can classify them based on their angle measures, and you can classify them based on their sides. Angle measures goes back to chapter 1. An acute angle is an angle what? Less than 90. An obtuse angle is an angle that's what? Greater than 90, but 180. Yeah, how about a right angle? Equals 90. You're going to use those same ideas when you classify triangles. So that first triangle that you have under the exterior angle theorem matches this picture, and we call it an acute triangle because it has 3 acute angles. Yep, an acute triangle because it has 3 acute angles. Oh, you're doing, yeah, there you go. Yep, triangle has 3 acute angles. Acute, we already talked about, means less than 90. So all 3 angles in an acute triangle should be less than 90. Your second triangle should look like this. It has 1 right angle, so we call it a right triangle. A right triangle has 1 right angle. Right here. You'd say a right triangle has 1 right angle. Yeah, then this is where if you already know them, I guess you don't really have to define them. But can a triangle have 2 right angles? Why not? Well, why can't it have 2? Good, because all 3 angles have to add up to 180. And Dawson, if I have 2 right angles, what's 90 plus 90? But I still have a third angle. Isn't that going to put us over? Good. So you can't have 2 right angles. The next one we have then is an obtuse triangle. Obtuse triangles have 1 obtuse angle. This is my 1 obtuse angle. It's greater than 90, but less than 180. Can I have 2 obtuse angles in a triangle? No, because if 2 90s, then I can't have anything over 90 twice. And then this last one, all 3 angles are marked congruent. It's called an equiangular triangle. I'll write it bigger. E-Q-U-I, equa meaning equal, angular meaning angles. Equal angular triangles have 3 congruent angles. Equiangular, 3 congruent angles. Yeah. Those are your 4 ways to classify a triangle based on their angle measures. It's either acute, right, obtuse, or equiangular. You can also classify triangles based on their sides. If a triangle has 3 congruent sides, we call it equilateral. Again, equa means equal. Lateral means sides. People talk about your lateral movement, your movement side to side. Equilateral, 3 congruent sides. The angle one, equiangular. Good job. Yeah, exactly that. An isosceles triangle, I-S-O-S-C-E-L-E-S, how you spell it, has 2 congruent sides. Isosceles has 2 congruent sides. And then your third way to classify a triangle based on sides is called a scalene triangle. And a scalene triangle has no congruent sides, no equal sides. All the sides will be different on a scalene triangle. So equilateral, the words are there. Equa means equal, lateral means sides, so they have equal sides. Isosceles, when I taught 6th grade, the 6th graders came up with a link and they said that isosceles sounds like I saw 2 of these. Isosceles, 2 congruent sides. I saw 2 of these isosceles, okay? And their link for scalene, the word scale is in it, like what you stand on to figure out your weights. If we picked 3 of you at random, most likely you are not going to weigh the same. You will have different weights. So scalene, 3 different side lengths. Those are the 6th graders' ways to remember them. If you have a different one, let me know. We should be down to number 1, where it says classify the triangle by its sides and angles, way down at the bottom. Make sure you read carefully, not only on your notes, but in your book and your worksheets and quizzes. One of the most common mistakes in this section is not seeing that it says sides and angles. All of these should have 2 classifications, one based off of their sides, one based off of the angle. So you should have 2 answers for each of them. Oh, okay. So take a minute here and classify those 4 triangles. You have 7 ways to do that at the top. Maybe you want to go. Kilgore, do you have that first triangle classified? What did you put down? Good. 2 scalene, 1 obtuse angle, and none of the sides are equal. Your second one, it's really my third one. Veronica, what did you get for this guy? Good, acute and isosceles, because they have these 2 sides marked congruent. I always forget how to spell isosceles, so I don't care if you abbreviate it. All right, my second one, your third one. Jack, what'd you get for this triangle? Yeah, your third one. Good, it's a right triangle because it has the 1 right angle. And then it's scalene, none of the sides are marked congruent. Awesome. Brady, how about the last one there? Good. Equilateral and equal angular. All sides are equal, all angles are equal. Equilateral, equal angular. Okay, classifying. Using our rules from today. The triangle angle sum theorem, all 3 angles add up to 180 inside of a triangle. Yes, but since they mark them congruent, I would rather see equal angular. But yes, I agree, it would also be acute. And then we have the exterior angle theorem that says an exterior angle equals the sum of the remote interior. In triangle ABC, the big vertices, angle ACB is a right angle, and they marked that for us there. And then it says segment CD is perpendicular to AB. Remember, perpendicular, where they intersect, they make a right angle. Again, already marked for us. We need to find the values of little a, little c, little b. I'm going to give you a minute here to see what you can come up with. A lot of times I think our brains want us to do things in order, whether it's numerical or alphabetical order. So you might do A, B, C. But to me, I think it'd actually be easier to go backwards and start with C and do CBA. So don't always go in order. Just look at what you know. Sarah, what'd you get for, I'm going to start with C. What'd you get for C? How'd you get 20? Good. You're using your angle addition postulate. These 2 angles, C and 70, have to add up to 90. So 90 take away 70 gives me 20 there. Good. Anyone else got B or A they want to volunteer? Kilgore? How'd you get A to be 70? Good. Perpendicular means they make not just one right angle, but 2, 3, or 4. So this guy has to be 90 over here. Then the triangle sum theorem says all three of them have to add up to 180. Add what you know and subtract. Awesome. Maddie, you got B? What did you get for B? Well, how did you get 20? Did you look at this triangle here, Maddie? Good. Triangle CDB. Triangle angle sum theorem says 70, 90, and B have to add up to 180. So what did you do? 70 and 90 gave you 160. And then you subtracted that from 180. Good. And you get 20. Good, good, good. Triangle angle sum theorem. Okay, hopefully, as I'm looking, don't flip it over yet. Some of you still have some room here by number 2. You don't need a lot of room. This question isn't on yours, but you can do it with me here. It says if triangle PQR is an equilateral triangle, find the value of x. Equilateral. What does it mean if a triangle is equilateral? The sides are equal. You don't have the picture, but I do. I'm going to mark that then. We have to get into that habit of seeing words like perpendicular and putting a right angle, or seeing equilateral and marking your sides congruent. Rose, what does it mean if things are congruent? They're the same, right? Same length in this case, since we're talking about sides. So what kind of an equation, Rose, can I set up to find the value of x then? Good. Set them equal to each other. To be congruent means to be equal. Subtract x. X plus 5 equals 35. Subtract 5, so what do we get for x? 30. Check it. What's 30 plus 35? 65. What's 2 times 30? 60. Plus 5. 65, right? So those two sides are congruent when I plug them back in. What would be the length of PQ? 65. Kilgore? Are those angles or are those side measurements? Good question, though. That will come up. Someone will do that. He asked if I could just throw a 2x plus 5 over here, since they're congruent, and say all three of those add up to 180. Gotta be careful. Are we talking about sides versus angles? Since these are sides, we wouldn't add them up to 180. All right. Go ahead and flip it over now. And number 3, go ahead and cross that off. We're not going to do any part of number 3. We're going to go all the way down to number 4, where it says find the measure of angle 3. Let's do. Take a minute and see if you can find the measure of angle 3 on number 4. Angle 3 on number 4 is this guy over here. Would you say that he's an interior or an exterior angle? Exterior. He's outside of my triangle. And he's formed by one side of the triangle and an extension of the other, so definitely an exterior angle. What do you think, Wagley? Did you get angle 3? What'd you get? Well, how did you do that? You just added those up. So Wagley, are you using the triangle angle sum theorem or the exterior angle sum theorem? Good. The exterior angle is equal to the sum of the measures of the remote interior angles. So if we take 45 and 45, you get 90. Anyone do it differently? Patty. Good. You can use the triangle angle sum theorem. Because Dylan, the triangle angle sum theorem says all three of these angles have to add up to what? Right, and if I use what Wegley said, 45 plus 45, I get 90. And 180 minus 90 tells me that this angle has to be 90, right? Therefore, the one adjacent to it, angle 3, would also have to be 90 because they form a straight line. Either way, you don't have to know the exterior angle theorem to find the values of an exterior angle. You need to know the triangle angle sum theorem, for sure. You don't necessarily have to know that exterior angle theorem. Remember, theorems are like shortcuts. If you do know it, sometimes it's less work. There's a second part to B, or to 4, part B. It says, is it true that if acute angles of a triangle are complementary, then the triangle must be a right triangle? Franson? Why? Why? Good. Acute angles of a triangle are complementary. It doesn't tell me how many of the acute angles. But what does it mean to be complementary? Add up to 90. How many? 2. So if 2 of the 3 angles add up to 90, and all 3 of them are supposed to equal 180, so 2 equal 90, what does that leave for the third angle? 90. And if a triangle has one 90-degree angle, one right angle, we call it what kind of a triangle? A right triangle. Okay. I'm going to write this out in like a sentence proof, kind of, like a complete sentence that you'd have to write in English. Yes. Explain. Okay, so I said, yes, if 2 angles add up to 90, the complementary part of it, then the third angle must be equal to 90 degrees by the triangle angle sum theorem, because all 3 angles have to equal 180. If 2 of them already add up to 90, then the last one must be 90. That's how I'm using the triangle angle sum theorem. Therefore, if a triangle has one right angle, because all that's left over is 90, it must be a right triangle. It's in a way like a proof. Notice how both of my sentences are written as conditional statements. If, then. If, then. So like if we were to put this in a proof, we could say if 2 angles add up to 90, so like measure 1 plus measure 2 equals 90 by complementary angles, then the third one needs to equal 90 by the triangle angle sum theorem. If it has a right angle, then it's a right triangle. Conditional statements. If something, then something. Using theorems and definitions that you know. Once you have that copied down, go ahead and do 5, 6, and 7. Find either the measure of angle 1 or the value of x, whichever it says to do. Sid, number 5. How'd you get that? Why? Good. 125 is an exterior angle, and the exterior angle theorem says that the measure of an exterior angle is equal to the sum of the 2 interior ones. In this case, it'd be 90 and 1. It's the one that's not touching it. Well, if 125 is supposed to equal the sum of the 2 angles, then subtract what you know, and you get your angle. Did you say 35? You guys agree? Good. Anyone else do it differently? Let me guess your way. Could you subtract this from 180 and get 55? And then use the triangle sum theorem and all three equal 180? Good. They're both correct. Okay? There's not just one way to answer these sometimes. There's multiple ways. Number 6. Paige, how are we going to find the measure of angle 1? You guys agree with her? Good. Good, good. All right, number 7. What do you think, Morgan? Why would they equal 180? Good, the triangle sum theorem. But how come when Kilgore asked us earlier on that other one, we couldn't set them equal to 180? Because what? Because they were side measurements. Good. Make sure you pay attention. Are the expressions on the inside or the outside? If they're on the inside, 97% of the time they're talking about angle measures. Okay, when they're on the outside, they'll be the side lengths. Most of the time, sometimes I get lazy, but I'll put angle degree symbols. So if there's degree symbols, they definitely have to be the angle measures. So just look at what we're doing there. Combine like terms quickly. 6x plus 15 equals 180. Subtract 15. 6x equals 165. Divide by 6, and what do we get for x? 27.5. You guys agree with her? It is. Well, how do we know for sure? Plug it in. So this one, I got this, 27.5. 55 plus 10 would give me 65. This one's got to end on a 0.5. 12, 82, 84, 82, 87.5. But how does that tell me if 27.5 is correct? Okay, someone add those all together. So it worked? Did you really add them, or did you just say that? Okay. Hey, Dawson, if I have a triangle that has an angle measure of 27.5, 65, and 87.5, how would you classify that based on its angles? Is it? Good. All the angles are acute, so it's got to be an acute triangle. Riley, how about this guy on number 6 that have angle measures of 15, 55, and 110? What kind of angle is, or triangle is this based on its angles? Why? Because it's got an obtuse angle. Good. Rain, how about triangle number 5? Good, because it has one right angle. Awesome. All right. Number 8. We have 5 parts here. You only have one picture there, but each of the 5 parts have different information. So if you're going to label it, just be ready to erase it with your pencil. Or you can just watch me. I'll label it up here, and you can write the equation from that. So on part A, it says find the measure of angle 3 if the measure of angle 2 is 70 and the measure of angle 4 is 42. We have to find the measure of angle 3. What did you get, Sarah? 97? That can't be right. Only because if one ends on a 2 and one's end with the 7. Okay, resubtract. 68. Do you guys agree with her? What theorem did you use? Yeah, the triangle angle sum theorem, which says that all three angles have to add up to what? 180. Good. Part B, second one. Find the measure of angle 5 if 2 is 76 and 3 is 90. Sorry, this will not be drawn to scale for all of these since it's the same picture but different information each time. Ben, did you get it? Oh. Well, which angle are we trying to find? Where's 5 at? Over there, would you say it's exterior or interior? Exterior. So what was that rule today about the exterior angles? You don't remember? It's the second one. What's it say?
The measure of each exterior angle of the triangle equals the sum of the measure of its two remote interior angles.
Okay, so sum means you have to do what math operation? Add the remote interior angles. Yes, it is. That would be your measure of angle 5. Angle 5 is an exterior angle, so the exterior angle theorem says that your exterior angle is equal to the sum of the remote interior. The remote means that they're non-adjacent to it. They cannot be touching that. So you just add those two together, and you get the measure of angle 5 to be 166. Anyone want to do it differently? Anyone find angle 4 first, using the triangle angle sum theorem? You did. You got 4 to be 14. Okay. That's another way you can do that, you guys. If you find angle 4 first, what do you know about angle 4 and angle 5? They have to add up to 180 because they form a line. So there's another way you can do that. All right, to see. Find the value of x if 1 is 4x, the measure of angle 3 is 2x plus 28, and the measure of angle 4 is 32. Well, since we're trying to find the value of x, we're going to have to come up with an equation this time, instead of just doing the easy subtracting from 180 stuff. Rashid, do you have an equation we could use? What's your equation you're using? 4x equals 2x plus 28 plus 32. Okay, do you guys agree with that equation? Why? Awesome, great explanation. Exterior angle theorem. The exterior angle has to equal the sum of the two remote interior angles. So 4x has to equal 2x plus 28 plus 32. 2x would equal 60. Divide by 2, and what do you get for x? 30. And how can we check if that's correct? You would plug it back in. 2 left. D. Find the value of x if 2 is 10x, 3 is 5x plus 40, and 4 is 3x minus 4. Finding the value of x, I have to come up with an equation to do so. Kate, any ideas? None? Do you see those 3 expressions they gave us for 2, 3, and 4? Good, set them equal to 180. Angle 2, angle 3, and angle 4 are all inside of the triangle, so the triangle sum theorem says they all have to add up to 180. 10x plus 5x plus 40 plus 3x minus 4 equals 180. 18x plus 36 would equal 180. Subtract 36. I'm writing too big. 18x equals 144. 8. 80. I'll make this one 80. 40 and -4. And that would make this one 20. Nice. What are you confused about? My equation or my algebra part? Oh. But do you understand how we got this first equation? Okay, that's what I care more about today. We'll work on the algebra a different day. All right, last one. Time we got here, 50? Dang. 54? 50. Measure of angle 3, find it. If angle 1 is 125 and 5 is 160. My little studious ones, those of you that went ahead, help me out. Clean? Okay, so 125 and angle 2 form a straight line, and they have to add up to 180. So 180 minus 125 gave me 55. Same thing with 4 and 160. Therefore, I get these two angles on the inside of the triangle. Triangle sum theorem says all of them have to add up to 180. So 180 minus 75 would tell us that angle 3 is 105. Yes?
Yay, one more.
It's online.